Hey everybody. So here we're going to do a quick tutorial on using R and RStudio to do repeated measures ANOVA, a factorial ANOVA, and then a mixed model ANOVA, or mixed model analysis in general. So let's get straight into R and we'll start loading up some data sets. Okay, so here we are in R. And the first thing we're going to do is import a data set that we're going to be using. And the first data set that we're going to use is called core temp, and it needs to be in the long format for R. So even though it's a repeated measures analysis that we're doing, we're going to be using the long format. So it will be called core temp long.csv. So I'm going to open up that file. And it's called core temp rm long. I forgot to say that. Now I'm going to give it the name core temp dot data. It's got headings and everything else looks good. I'm going to click import. Okay, and we can see here our data looks pretty good. Now I'm going to go back to our script that we've been using down to the bottom. Now, the first thing we're going to do is we're going to load a bunch of different library packages. The packages that we're going to be using, some of them you've had installed, and some you might not. But I'm just going to type them out in terms of the library, and if you need to install those packages, go ahead and do that, and then you're going to have to load the library. So, the first one is called EZ, and it's used for EZ ANOVA. So library simply EZ or EZ. So load that, and then we're going to load multcomp. So this allows us to do some multiple comparisons. We're going to load estimated marginal means, EM means. We're going to load CAR, companion to applied regression. We're going to load R statics. We're also going to load a couple new ones called LMER and LMER test. Okay, so I'm just going to run that entire set to load those packages. Now, you may have to install those packages first, but once you do, you should be good to go. Make sure you load those libraries up and you should be good to go. Now, we're going to run our repeated measures ANOVA on our core temp data. So I'm just going to close down these files at this point. Okay, so maybe the first thing that we're going to want to do is also use our options scipen equals 999. And I'm just going to hit Control Enter to run that because we want to be able to see the ANOVA output without scientific format. If you want the scientific notation, that's fine. Don't use this command. But I like to see it without. So the next thing we're going to do is we're going to use our base here. I'm just going to grab an attach and detach section, copy and paste it here. And I'm just going to remove everything in between. And now the data that we're going to use is the one that we've just installed or just loaded up, which is core temp.data. And then we're going to attach the data frame. So the first thing we're going to do is we're going to try using EZ ANOVA. So we're going to create a new object called core temp dot data and core temp dot model. And into that, I'm going to put easy ANOVA. So easy lowercase and ANOVA uppercase. Then we have to do a few things. We have to specify the data in this case. So I have to say data equals core temp dot data, comma, and then we need to specify a few things. And each of them get the specific format where it gets dot and then something in parentheses. So the first one we're going to do is call it the dependent variable, right? We're going to use temp as our dependent variable. Okay, so the next thing I need is the within, and that's going to equal, that's within ID is subject. And that's different than our within factor. So our within factor is actually going to be time. Then we're just going to specify type equals 3. So we're going to do type 3 sum of squares, and I'm going to specify detailed equals true. Okay, so I know that's a lot of things. Well, I'm going to put that detailed equals true. So it's a lot of things specified, but that should give us our model. And then what we can do is we can just do a summary of that model. And I can just ask for the model and what's in the model itself by just saying core temp dot model. Okay, so why don't we just run that the way it is right now? So this should all be able to run because I've loaded up my libraries that I need already. And if I run this, what we see is it's created a new object. And I've got an output here. So what we see is here's my summary of my model, which just gives me sort of a few different items. There's an item for ANOVA, an item for a Mauchly's test of sphericity, and sphericity corrections. And then when I look at that model, just by looking at core temp.model or typing that in, I get my ANOVA table. And this gives me my effect of time with degrees of freedom 5 and 35, F value of 49.27, and P value is way less than 0.001. Mauchly's test of sphericity is significant at P is less than 0.05, and that is 0.012. And we've got sphericity corrections here. And our greenhouse geyser epsilon is 0.529. So because it's 0.529, we're going to use the greenhouse geyser corrected p-value, which is still way less than 0.001. If it were greater than 0.75, if this greenhouse geyser epsilon were greater than 0.75, we should consider using the Winfeld corrected p-value because it is a little less conservative. Greenhouse geyser could be too conservative at that level. Okay, now that we've seen our ANOVA table, we might want to see where our differences actually lie. So after this, let's do some pairwise tests. So the first thing we're going to do is use pairwise.t.test right there. And what we're going to use is temp is our dependent variable as a function of time. And then we have to specify that paired equals true. Then we could specify an adjustment method, but let's just leave it this way for now. So if I run this again, what we see is we've got our pairwise comparisons that it's done after outputting our ANOVA table, and it's used a p-value adjustment method of a Helm-Bonferroni, which is fine. Now, we see that core temperature 0 is significantly different than core temperature at 15 minutes, 30 minutes, 45, 60, and 90. Then we can go through all the other ones. Core temperature 15 is only different in comparison to 45, 60, and 90. And core temperature 30 is additionally different compared to 45, 60, and 90. Core temperature 45 is significantly different in addition to the ones we've talked about before to core temperature 90, and then 60 and 45 seem to be significantly different from one another. So the next thing we're going to do is figure out how to do a factorial ANOVA, or a two-way ANOVA using R. So the next thing we're going to need to do is load up a new set of data. And we're going to go in and load up the BeerGoggles.csv data. Now, I'm just going to name this BG for BeerGoggles .data. And this all looks good. Note that we've got a couple of different variables here that look numeric, but alcohol here is actually going to be a categorical variable, so we're going to need to turn that into a factor because it will think that it's a numeric variable. So I'm going to import that data set, and it looks good otherwise. Now, what I'll do is I'll start off with my base and I'm just going to change the input to bg.data, and I'm just going to get rid of all the stuff that's in the middle. So remember, I already said that we need to change that alcohol variable to be a level or a variable that is a factor. So it has various levels. So the way we're going to do that is we're going to call bg.data $alcohol. Into that, we're going to put as.factor and the same thing, bg.data alcohol. And that's going to turn that into a factor. I'm just saying Control Enter so it ends up being done. Okay, so I'm going to pull this actually out and put it above. So in order to do this first analysis, we'll use the AOV like we did for the analysis of variance for a one-way ANOVA. So we're going to call it bg.model, and into that we're going to do AOV attractiveness as a function of face type by alcohol. Then we're simply going to do a ANOVA of bg.model, or it would be important if we have an unbalanced design, we should use capital A ANOVA, which actually uses the ANOVA function from the car package, which will use a type 2 sum of squares, which is important for when we've got an unbalanced design. A type 1 sum of squares is used by default in the base package ANOVA, and sometimes for an unbalanced design it's not going to work. It's going to create a different value that we're going to end up with. But we should see that these end up being the same value. Okay, so why don't we just run that? So let's look at our data and our output of this. Remember, this data is basically just saying we've got a bunch of different face types, pictures, and we're asking people to rate those images on the rating of attractiveness. And we've got groups of people that either had no alcohol, a little bit, or a lot of alcohol. That'd be 2 drinks or 4 drinks. And we want to see if the ratings of attractiveness for attractive people change and the ratings of attractiveness of less attractive people change as well. So we're going to run this analysis. And now what we see is I ask for an ANOVA table from both the different types of functions, but we see that the output is basically the exact same thing here. So 15.826 for the factor face type, and P is 0.00029. The main effect of alcohol has an F value of 6.04 and a P value of 0.0049. And there's a significant interaction between the factors face type by alcohol of 8.5, and probability is 0.00079. If we want to do multiple comparisons, one way we can do that is by using the EM means package, or estimated marginal means. And we're going to look at the model, so it'd be bg.model, comma, pairwise, and we're going to say as a function of face type by alcohol. Now, if we run this, I spelled alcohol wrong, apparently. There we go. That should be it. Now, what we see is the EM means, or estimated marginal means function, gives us the estimated marginal means and confidence limits, but then does pairwise comparisons using a Tukey method for a family of 6 estimates. And what we see is we get differences between attractive at 0 and unattractive at 0. We see that we have a p-value of 0.002. And we could go through and determine where all these differences lie. So the last thing we're going to do is we're going to run a mixed ANOVA using R. Now, what we're going to do is use a data set that is similar to the one we used for the repeated measures. But whereas we have different core temperatures with increased duration of stationary cycling, however, we've got 2 groups. We've got males and females. So we've got a between groups factor, and we've got a within groups factor. The within groups factor being time, and the between being the groups, males or females. So let's load up that data set. And because we've already got one called coretemp.data, I'm just going to call it coretemp.mixed.data. And the file name is coretemp.mixed.long.data. Remember that R likes its data to be in the long format. I'm going to import dataset, coretemp.mixed.long.csv. Now, I'm just going to call this coretemp.mixed.data. What we see is we've got subject, sex, temperature, and time. And I'm going to import that, and the data looks pretty good. So we go back, and I'm just going to copy everything from coretemp.data here, because it's going to make my life easier because it's all very similar. So I'm going to call this coretemp.mixed.data, and we're going to call this coretemp.mixed.model, summary, coretemp mixed.model, do a core temp mixed, and then I'm going to comment this out because this function of pairwise isn't going to work with our mixed data. The other thing we need to do is change the functions in here. So we're going to use in the first set easy ANOVA to run this. So core temp mixed.model, going to use easy ANOVA, and the data is going to be core temp mixed.data. So what we see here is we've got our dependent variable temp, our within ID of subject, our within of time, and we need a new variable and our variable is going to be called between equals sex, and add a comma in there. Type 3 and detailed. So I'm missing an X in there. Just want to make sure I've got everything typed out correctly, and I'm going to run this whole set. So I got a bunch of errors. So can't find core temp mixed.data. And I thought I named it with a capital temp and a capital mixed, but it turns out I didn't. It's core temp with a small t. So rather than reloading the data, I'm just going to change everything in here. So I'm just going to call this core temp mixed.data. I don't have to worry about the rest of it except here. So the rest of it should work fine because I've called my core temp with the capital T in the model, and the model here in the model. That's all correct. It's just the data that need to be renamed. I'm going to run that. And what we see is, first of all, tells me a couple of different issues. It's converting subject to a factor, and time to a factor, and sex to a factor. And what we see is I get a main effect here of time with an F ratio of 73.42 and a p-value that's really small. And I have a main effect of sex, F ratio of 28.285, and p is less than 0.001. And I have a sex by time interaction where my F ratio is 18.23 and p-value is super small. And there's some corrections for sphericity because they are significant, and we've got a greenhouse geyser epsilon of 0.459. Now, we would like to know where our differences lie in this case. So what we can do is we can actually use another package to create our ANOVA model that allow us to use EM means to do the pairwise comparisons afterwards. Now this will use a package that we haven't loaded yet called AFEX or AFEX. So I'm going to add to the top here library AFEX. And I'm just going to run that command using Control Enter. And it's going to load that library. Now what I can do is I can create a new model, and it's going to be very similar to the command used for core temp mixed model. So I'm going to paste it there. I'm just going to call it core temp mix 2.model. And its command is AOV_EZ. Now it uses the data command, but then some of these variables are a little bit different. So instead of dv dot brackets temp, we're just going to put quotes temp, but it doesn't use the brackets or the dot. ID gets the same treatment. Just get subject, within is time, between is sex. And then we can just close the bracket. After that, we can just look at that model, core temp mixed 2.model. And then what we can do is we can use the em_means command like we've used here. And this time it's core temp mixed 2.model. And pairwise is going to be time by sex. And now if I run that entire command, what I end up getting is an ANOVA table that looks very similar to what we had before. We have an F ratio of 73.42, but now we have the estimated marginal means and we've got all of the different comparisons. And what you can see is that we can compare, for example, females at time 0 to core temperature in females at time 15, and we see that there's no difference. Of course, we can compare females at time 0 to all of the different times as well, and we can see that they are different at significant levels provided here. Then we can make all the other comparisons we would like to. For example, are males at time 0 different than males at time 15? And that is the case, yes. So we can make any comparisons both between times or between males and females at any given point. So all of the different pairwise comparisons are here, and you can specify which ones you want to look at. Okay, so that's pretty much it for all of the repeated measures and factorial ANOVA and mixed model ANOVA. Hopefully that gets you started and you're able to do some of these analyses pretty standard in R.